Kaya's Arm. Today is June 30th, 2023, and today I'll be showing you how we run a cross-match major-minor in-house. So we're going to start by having our two EDTA samples. For this one, we have two blood type A cats that we will be cross-matching. One is the recipient and one is the donor. So for the recipient, we have Oliver, and for the donor, we have Ruby. So we're going to go ahead and get started. So we've already collected our EDTA from our patient, and we have our EDTA from our donor. So what we're going to start with is we're going to take both samples and we are going to place them directly across from each other to balance the centrifuge, and then we are going to run that for about 5 minutes. On our machine it only goes up to 4,000, so we're going to spin it down at 4,000 for 5 minutes. So I'm going to go ahead and stick these in and then I will show you. Okay, so we have balanced our machine. So here we have this one on the outside here and this one right across on the outside on this side. So now we will go ahead and close our machine. It's set to 5,000 and we're just going to decrease this to 5 minutes and we will go ahead and get started. So I'm going to go ahead and take a pause here and then we will show you what to do next. Okay, so we have finished our centrifuge separation of our plasma and our red blood cells, and just to give you see what this looks like, so here on top we have our plasma and then you have all your red blood cells that are stacked at the bottom. So the next step for us is we are going to separate them. So we will take a clean pipette and a labeled tube. So this will be Oliver's plasma. So we're going to separate the plasma into its own tube. Now for this, I'm just using a plastic empty tube. This is a red top, so it has nothing in it. So I am just now going to take my pipette and I'm going to suck up all of the plasma that I can from the top. You should be able to get practically all of it. You want to try not to get any of the red blood cells mixed up with your plasma. So now that I have successfully separated my plasma, I will empty that into this clean tube here. So now that we've used this pipette, it is done, so I'm going to throw it away, and we're just going to set the plasma aside. So now I have just Oliver's, the recipient's, red blood cells in a tube by itself. Alright, so we're going to do the same thing with our donor. So again, you're going to have your labeled tube for your plasma. Take a clean pipette, and we're just going to take off the plasma from the top. Again, try not to get your red blood cells. And again, goes into the empty tube and this gets thrown away. Alright, so then again, we'll set this plasma to the side. So now we have our donor and our recipient's just red blood cells. So next, what we're going to do is we're actually going to wash our red blood cells with saline. So what I have here is a clean, sterile urine cup, just so that I can put my saline in something. Okay, so this is sterile saline right here, pulled up from a sterile saline bag. I'm just going to empty in here to make my pipetting a little easier, and then we can throw that away. Okay, so what I'm going to do is I'm going to take each of my red blood cells, and for every 1 drop of my red blood cells, I'm going to mix with 20 drops of my saline. And so in order to do this, I am actually going to grab more empty tubes. And so for this, again, I'm just going to take another empty plastic tube. So then I will take, again, a clean pipette. I will take, and I will soak up all of my red blood cells that I can. Okay. Here I have just red blood cells. So then for every 1 drop of this, okay, so get a true drop. Perfect. Every 1 drop of this, I do 20 drops of saline. And so I'm going to suck up my saline from here. So then I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that is my sterile saline. And so we will do this for both. And so we are just going to essentially just wash it and put it together. So then I will do that for each of them. So I will do that with the other one as well. Okay. Okay, so the suspension wash that we make with 1 drop of red blood cells and 20 drops of our sterile saline, we are going to do that 3 times. But what we're going to do is we're going to make the first mixture for the donor and the recipient, and then we're going to centrifuge that. Once that is done centrifuging at the same time as we did it the first time, we will remove the saline from the top, and then we will add 20 more drops of saline. We will centrifuge it again, and we will do that process 3 times. So I'm going to go ahead and get those centrifuging, and I'm going to do the whole 3 process step, and then I will show you at the end what it looks like, and we'll keep going. Okay, so after our 3 dilutions, this is what we get with our red blood cells at the bottom. So what I'm going to do is I'm going to go ahead and take the saline off of the top of the red blood cells in order to do the actual major, minor, and recipient crossmatch. And we do this again for both the recipient and the donor. So go ahead and take that off, and I'm left with my red blood cells. So then what I'm going to do is I have 3 tubes labeled with control, minor, and major. And so what I'm going to do here is I'm going to make each of the tubes based on what they need. So I am going to pull out my plasma for each type of case where it is the donor recipient. And so what we'll do here is I have a clean pipette for each type of sample. So 2. So we're going to start with our major. So in our major tube, we're going to do 2 parts of our recipient plasma. So for our major, we're going to do 2 parts. So we're going to do 1, 2 of our plasma. And then we're going to do 1 of our donor cells. And so that's where I'm going to go here. And I'm going to take 1 donor cell. And we're going to do 1 drop of our donor cells. Okay, so then we're going to go ahead and close that. So we're just going to mix this gently. Mix, mix, mix. And so we are going to set this aside for 15 minutes, and it's going to incubate for at room temperature. Okay, so then sorry, some tube disturbances here. Okay, so put our major aside and let that incubate for 15 minutes. So our minor is the one we're going to do next. So here's our minor. And so for this one, we are going to do our okay, now moving on to our minor crossmatch. So for our minor crossmatch, we are going to do our donor's plasma and our recipient's cell. So again, it's going to be 2 parts plasma. So this is our minor tube. So 1, 2. And 1 part recipient cells. Into our minor tube. Okay, so from here we're going to put the cap on. We're going to do just like what we did with the major, and we're just going to slightly invert and mix the recipient plasma, or the donor plasma with the recipient cells. Okay, now that we have gently mixed that, we get this, and we're going to set this aside for 15 minutes and incubate for at room temperature. So lastly, we have our control. So for our control, it's going to be the recipient plasma and the recipient red blood cells. So again, we're going to do 2 parts plasma. 1, 2. And the recipient cells. Okay. Okay. So then again, we will mix this gently. Alright, so then we have that, and we'll incubate that again at room temperature for 15 minutes. So after that, we are going to centrifuge them for 15 seconds at the, our machine only goes up to 5,000, so we will do it to 5,000 for 9 minutes, and then we will go from there. Okay, so after making our major, minor, and recipient cross-match tubes, we let them sit for 15 minutes incubating at room temperature, and then we centrifuge them at 5,000 for 15 seconds. So once we get that, what we're going to do is we'll start with our major, which we have here. It's very hard to see in the video, but essentially what we're looking for here is any hemolysis in the plasma portion of the supernatant. Well, the supernatant is the plasma portion. And so when I look up here for this, for the major crossmatch, which is our recipient plasma with our donor cells, there's no hemolysis, which is good. So then we go over to our minor, which is our donor plasma and our recipient cells. Again, we look at the supernatant, which has no hemolysis. And lastly, we look at our control, which is the recipient's plasma with the recipient's red blood cells. And again, we look at the supernatant. There is no hemolysis here as well. So the next thing we're going to do is we're actually going to resuspend the cells into the mixture. And to do that, I am just going to lightly tap it with my finger until everything is a little bit more mixed up. And essentially what we're looking for here is any macroscopic agglutination, so if any of the cells are sticking together. And so I'm just going to tap till we're mixed up, and then I'm going to look throughout, and I do not see any macroscopic agglutination in our control, which in that case is a good thing, because you wouldn't want to see agglutination with your own plasma and red blood cells. Next, we're going to check out our minor. Again, just tapping it lightly with our finger till it is mixed up. Alright, and then we're going to take a look, and there's no macroscopic agglutination. And again, the minor is our donor plasma with the recipient cells. Lastly, we're going to do our major, which is our recipient plasma and our donor cells. And we're just going to lightly tap. And again, we have no macroscopic agglutination. So on all three so far, we do not have any agglutination with the major, minor, or control. So far as we can tell, this donor with this recipient are compatible. So lastly, we're going to do our microscopic evaluation. And so with this, we are basically going to take each one of our major, minor, and control, and we're going to make blood smears. So we are going to put a small drop onto a slide, and you can kind of like move it around on the slide as well, and just look for any agglutination on the smear. And thus far I do not see any. And the next thing we're going to want to do is actually make a smear that will go on the microscope. And so for these, we're just going to do our normal push smears. And then this will leave it open to look at under the smear. So this right here is our major smear for microscopic evaluation. So next we move on to our minor, and we're going to do the same thing. So again, we're just going to take our minor sample with a clean pipette. Gonna soak up a little bit. Again, we're going to put a small drop on the slide, move it around, and see if we have any agglutination. And here we do not. And so again, we're just going to take a clean slide to do our smears. So we're just going to do our normal push smears. Perfect. So far, so good. So far, so good. So then we have our minor smear. All right, and then lastly, we do our control. So clean pipette, soak up a drop. We have our recipient control, and they're all labeled. You always label your slides. All right, so then we're just gonna swirl it around, look for agglutination, which there isn't any. It's hard to see on the video, but we'll have pictures in the PowerPoint. So then we will make our smear. And then again, that will be used to look at on the microscopic evaluation of our crossmatch. And that is how you do a feline crossmatch with a major, minor, and a control.